Hello, friends. Let us continue our last lecture on diesel engines. This time, I am going to discuss with you the performance testing of diesel engine. It means that you are checking the performance of diesel engine by conducting some tests. Okay. So, what is written here? It is the performance of diesel engine focus on the power and efficiency. So the performance of engine is based on the power and efficiency. So what you are doing, you are actually we are checking the power and efficiency of a diesel through check its performance. So these are two. There are other parameters, but the main motive of the performance of the diesel engine is that we are checking its power and this efficiency, and the engine varies with the parameters of the engine like piston speed, air fuel ratio, compression ratio, inlet air air pressure, and the temperature. So these are the characteristics, or you can say parameters, on which the performance of the engine depends. That is piston speed, air fuel ratio, compression ratio, and air pressure and temperature, etc. The two usual conditions under which IC engines are operated are, the IC engines are operated under two usual these conditions. First is constant speed with variable load, and second is variable speed with variable load. That means this you are conducting tests, or you are plotting graphs between constant speed with variable load and variable speed with variable load. Is this first this condition, that is constant speed with variable load, it is applied for the AC generators, where keeping speed constant with variation with variation in load. And this second part, that is variable speed with variable load, it is applied on the on the engines, in automobiles, railway engines, and tractors, etc. So these are the two conditions on which you can, mostly this IC engines are operated. Now let us move on the what are the parameters to which we have to study for checking the performance of any diesel engine. A series of tests are carried out on the engine to determine its performance characteristics, such as indicated horsepower, brake horsepower, frictional power, mechanical efficiency, thermal efficiency, fuel consumption, and also specific fuel consumption, etc. These are all these characteristics are parameters which we have to study, and they, because they are very important for checking the performance of any diesel engine. And you can also say these are design. You can also say these are called the design considerations that before designing any engine, diesel engine. So these are the design parameters which we have to take into consideration for the design of the engine. So let us first discuss what is. I hope that you have already studied these topics in your IC engine part in previous semesters, but still I am going to discuss these things because they are very important topics, and you should those people who know these, they can skip and or they can listen. It is up to you, but those who don't know, they can they can review their concepts after watching lecture, and also I will send you the note on this lecture. So first is indicator mean effective pressure. It is designated as IMEP. So what is this indicator mean effective pressure? It means it is the actually it is related with the indicated horsepower. So I will discuss later what is indicated horsepower, but for time being you see that it means from its word meaning is that is it's indicated with the indicated horsepower. Now what is the definition of this indicator mean effective pressure? In order to determine the power, the power developed by the engine, the indicator diagram of the engine should be available. So to determine the in order to determine the power developed by the engine. So the power develop करने के लिए हमें indicated diagram की जरूरत होती है एक इंजन को डिजाइन करने के लिए, ठीक है. सो यू नो दिस व्हाट इज इंडिकेटेड डायग्राम. इट्स एक्चुअली a diagram that which is plotted between pressure and the volume, and it is a closed diagram, that is, you can say it is a cycle type of diagram. And it gives you that gives you the this value of measurement of this indicated mean effective pressure. And we are as you know that this area under PV diagram gives you the total work done per stroke. And this means that since this indicated diagram you can see here from the area of the indicated diagram, it is possible to find an average gas pressure which, while acting on the piston throughout one stroke, would account for the whole network done. So this pressure is called the indicated mean effective pressure. I will dictate again here. In order to determine the power developed by the engine, the indicated diagram of the engine should be available. So from this area of indicated diagram, it is possible to find an average gas pressure which, while acting on the piston throughout one stroke, and would account for the network done. This pressure is called the indicator mean effective pressure. So this is a full process about shown the what is the actually indicator mean effective pressure. Now coming on the this brief definition, what is indicator mean effective pressure? The average pressure produced in the combustion chamber during the operating cycle. It is the expression of the theoretical frictional power known as indicated horsepower. So from here you can see that indicated mean effective pressure is called the brake mean effective pressure plus frictional mean effective pressure. This is indicated mean effective pressure. Now when coming on the what is mean effective pressure, actually you must know this already. Mean effective pressure, MEP, it is designated as MEP, but it is small MEP here. It is equal to work done per cycle divided by swept volume. That means work done per cycle divided by swept volume gives you mean effective pressure. And indicated mean effective pressure is also a mean effective pressure, but it is related with the indicated horsepower. Okay, this is the main difference between the two. So now coming on this what is, and we are using here indicated diagram. I have mentioned here indicated diagram. So now I have written here the what is the definition of indicated diagram. The cylinder pressure variations versus volume can be plotted with the help of indicator. Thus the resulting counter, it means counter means the closed graph. The counter called indicated diagram will be closed one, and the area enclosed by the counter represents the work done per cycle. The area of the indicated diagram can be measured by counting the number of squares or with the help of a it is PLA and a planimeter. Okay, so it's an instrument that is used for the this measuring the area of the indicated diagram. Or you can also by manually you can also calculate the area of the indicated diagram by drawing rectangles which use the required area of the indicated diagram. Also that area is equal to work done per cycle. So now we must know what is indicated diagram now. So let us move on the next topic, that is indicated horsepower. It is the actual power within the cylinder of the engine due to combustion. So you can briefly say that indicated horsepower means that power which is developed by the cylinder of the engine. That is, it is the actual power developed by the cylinder of the engine. It is the actual power developed by the cylinder of the engine. So it means we are here considering all the losses in the indicated power. So now what is the formula for indicated horsepower? It is equal to this PM into LAN, LA capital N small n divided by 4500 into K. PM is equal to indicator mean effective pressure. It is unit in kg per centimeter square. L is equal to length of stroke. A is equal to piston area. N is equal to speed, that is RPM or speed of the crankshaft. And this is called small n is equal to number of cylinders. And because as you know there will be single cylinder engine or multi-cylinder engine, that is why small n is mentioned here. So K is the constant. It is equal to 1 for 2-stroke engine, and it is called 2 for 1 for 2-stroke engine. It is called 2 for 4-stroke engine. So this is all about what is indicated horsepower. Now let us move on the important part, that is brake horsepower, BHP. So as you know, I have told you that indicated horsepower is the total or actual power developed by this engine. Now brake horsepower means net power you are getting that means net power utilized by you when it is, or you can say that it is the power generated by the crankshaft. So that means brake horsepower is the net power. That means it is equal to indicated power minus loss, minus power losses in due to friction or other losses. So brake power, it is defined as the net power available at the crankshaft. It is found by measuring the output torque with a dynamometer. So I told you this indicate brake horsepower is the net power, but it is measured. It is found by measuring the output torque. So we are measuring this indicated this brake horsepower by measuring the output torque with a of the output torque of the crankshaft with a dynamometer. So dynamometer is a device which is used to measure the torque of the shaft. So you can, in mathematical language, you can say brake horsepower is equal to 2 pi nt divided by 4500. So this n is rpm and t is the torque. T is torque output in kg meter. So now let's move on. What is frictional horsepower? So as I told you that there are there will be a friction. You can say also wear and tear between the moving parts in the in any engine, that is it is diesel engine or petrol engine. So there also, because of this friction between the moving parts in the engine, there will be frictional losses in the form of heat or in the form of mass. So this frictional horsepower, so in according to this we are measuring what is frictional horsepower. So it is designated as FHP and it is equal to indicator horsepower minus brake horsepower. Okay? So indicator horsepower minus brake horsepower gives you frictional horsepower. So it is utilized in overcoming the frictional resistance of the rotating and sliding parts of the engine. Okay, so now the this fifth part of it is indicated thermal efficiency. It is designated by N small I, indicated thermal efficiency. Now what is the formula for indicated thermal efficiency? First of all, we'll see its definition. It is defined as the ratio of indicator work to thermal work. So indicator thermal efficiency is equal to is the ratio of indicator work to thermal work. That is it is equal to indicator horsepower into 4500 divided by this W into CV into J. It is equal to heat produced by heat given by the W kg of the fuel. So you can see here that this indicated thermal efficiency is called indicated horsepower ratio between the indicated horsepower and the energy given by W kg of fuel. W is equal to weight of the fuel supplied in kg per minute, or it is, you can say it is the fuel it is the amount of fuel supplied per minute, or you can say mass this quantity of fuel, and also CV is caloric value of the fuel, oil in kilocalorie per kg, and J is the joules equivalent whose value is 427. So this is the what is indicated thermal efficiency. And now coming on the brake thermal efficiency, or you can see also overall efficiency, or you can see also this is the net efficiency. Okay? So brake thermal efficiency or overall efficiency, it is defined as the ratio of brake output to the thermal output. That means brake horsepower divided by energy given by W kg of the fuel. That is total energy given by the fuel. And so this brake thermal efficiency is equal to brake horsepower divided by energy given by the fuel that you are supplying to the engine. That fuel is the weight of that fuel is W. And similarly, mechanical efficiency Nm, it is designated mm is equal to brake horsepower divided by indicated horsepower. Okay? So you should remember all these definitions and formulas, and all the these individual parameters or this notations. You should know all these things. I hope you can also understand it very clearly by using this note, and I will upload you this note on Google Classroom. Thank you very much.